Yeah, as an environmental chemist, I'm interested in understanding the sources of chemical pollution in the Earth system. And in my group, we have a strong focus on the chemical analysis of particulate matter in the atmosphere. So we study the composition of these particles because we still don't know exactly what is in the air that we breathe and which pollution is washed out from the atmosphere into surface waters. In this respect, there are many links to the profile area sustainability and biodiversity. For example, we can study the occurrence and the distribution of organic pollutants, such as pesticides or industrial chemicals or even toxic emissions from wood combustion. And to me, it's quite surprising how little we actually know about the concentration and the spread and the fate of these chemicals in the environment, and how much they transform and basically in the end are washed out by rain and go back into the aquatic environment. So of course, in the end, we have to understand these processes, and these processes can be modeled. But in the end, our contribution is to go out into the environment and measure and come up with numbers that the modelers can use to validate their models. So I see RobustNature as a great platform to initiate the gathering of people who do relevant research on the big environmental problems and the big global challenges. Like understanding, for example, the effect of chemical pollution on biodiversity loss. And as I mentioned previously, we measure organic pollutants in the atmosphere, and together with the ecotoxicologists from RobustNature, we can then evaluate the resulting effects of chemical pollution onto the environment. And thinking in a more transdisciplinary way, we not only have to identify risks or come up with new dangers through new chemicals, but we also have to think about solutions and how society is willing to transform into a more sustainable future. This is possible within RobustNature, and I'm happy to contribute with our work to this great initiative.